Hi there. I'm going to be talking about just chemical equations that we use to represent chemical reactions, and then there's 5 common types of chemical reactions. So, when we have a chemical change, we will be writing out shorthand chemical reactions. So you have to realize these are changes where the bonds of different molecules and compounds are actually broken and then new bonds are formed. So the new things are going to have different properties than what you start with. So one thing I want you guys to know is, and I think you might remember this from ninth grade, everything on the left side of the yield sign, this is a yield or it means produce or make. Everything over here is called a reactant. And then what's on the right side is called a product. So there's 3 types of chemical equations that we're going to use. Word equations are sentences where you just say what's happening. So sometimes we'll take these and actually translate them into the chemical shorthand formula equation like we have down here. So here's the sentence, here's the formulas, and then it's also possible sometimes we'll visualize this, and down here it kind of shows you like pictures of what we're doing. But every one of them has the yield sign, or they talk about it right here. So we will talk more about each of those types very soon. So this is just kind of going over what I had already covered, that your reactants are on the left of the yield sign, and those are what you're going to start with. And then once the reaction is happening, then you're going to produce what's on the right side. These are symbols that you're going to commonly see. I would recommend maybe putting these in your notes. I think most of them are pretty common sense. The yield is the arrow. S is for solid. So sometimes, like if we're dealing with like a metal, like copper, we would write a little subscript of the letter S. L is for liquid. So water usually is a liquid. Sometimes it's a gas. And then you can see we also have aqueous. A lot of times, and we're going to see this in our class, that a lot of the things that we deal with are going to be dissolved in water, otherwise they wouldn't react. So for example, sodium chloride dissolved in water, we would do that and put a little AQ. Gas, so sometimes I think there's a lab that will make some hydrogen gas, which is really cool because we can have a little explosion. We would put a G for gas. So those are just some common things that you're going to start to see in these chemical equations when we write them out. Another thing you're going to see are diatomic molecules. And what this means is these highlighted elements on my periodic table here are going to never be alone. So when you see hydrogen, for example, pure hydrogen gas, it's always going to be H2. We would never ever see just hydrogen by itself. This is when it's by itself though. If it's in a compound, it might be H2 like water, or it might just be HCl like hydrochloric acid. So this is just when they're by themselves. I have a little saying called Brinkelhoff. These are the ones that are diatomic. So bromine is, iodine is, nitrogen, chlorine, whoops, I was going to say carbon, but nope, chlorine, hydrogen, oxygen, and fluorine. So that's the highlighted elements. So you can remember them like a 7 with hydrogen, or that little saying to help you. So how do we write them? Just like I was. So bromine, iodine, nitrogen, and so on. How do we name them? We actually, if they're all by themselves, we just name them the way they are in the periodic table. So we don't change their endings. So it'd just be bromine, iodine, nitrogen. So this is, like I said, only when these are by themselves, but once they're in a compound, they don't have to be in pairs. So example, if I have bromine in a compound with aluminum, remember aluminum's +3, bromide, the ion is minus, so I end up with AlBr3. But it is possible, sometimes you'll have to, if you, for example, let's say you have barium with iodine. Now, just because of using crisscross and balancing their charges, we do end up with BaI2. But that's because of the barium, not because it's diatomic. So now we're going to talk about 5 types of chemical reactions. These are just common types of reactions. There's many, many more that don't fit into these categories, but we're going to see these quite a bit in the labs that we do. So let's see if I can scroll down. So the first one is called synthesis. This is when you're making, the giveaway here is that you'll only have one product. Whoops, and I have, kind of silly pictures that can kind of help you with this. So you'll have one or more either, elements or elements and compounds over here. And then on the right side, you're only going to have one thing. Then we kind of have the opposite of synthesis is decomposition. And this is when the giveaway is that you'll always only have one thing on the reactant side, and then you'll have more than one thing on the product side. So my computer thing is kind of possessed. So again, you can see my silly cartoon would be kind of like the bad breakup. So this can be a compound breaking into just elements, or it could be a compound. It's always a compound breaking into maybe an element and another compound. Single replacement reactions. This is where you're going to have a single element and a compound as the reactants. And then on the products, you're also going to have a single element and another compound. So this is, sometimes this is, a lot of times it's a metal. So I always think it's kind of like the lonely guy. Lonely guy, he goes in, he cuts in, they're dancing and takes this metal and replaces them. So now this metal's by itself, and now this metal is with the non-metal. So you can see, my little cartoon, lonely guy. This guy's happy, he's dancing. Now he's happy in the compound, and now this guy is sad and by himself. And then we have a couple more. So the next one we're going to talk about is double replacement. So this one, you're always going to have a compound and a compound, makes a compound and a compound. So what's happening is I always think of it as the cations, the first one, usually a metal, they're going to switch spots. When you get over here, now this cation is now with this anion. This cation still comes first, is with that anion. So in this example I have down here, the sodium and the silver are going to switch spots. Sodium comes over with the nitrate, silver goes over and it's now with the chloride. So here's an example with cartoons. He goes in his place and then he goes where he was to end up over here. Let's go. One last type of reaction is combustion. These are reactions where you have a hydrocarbon, which is some kind of compound that has carbon and hydrogen, and sometimes oxygen, and then it reacts with oxygen and we get water and carbon dioxide. So these 3 things are constant when you have a combustion. So example here, so X and Y are just telling you that the formula of this can change, but it will be something with carbon and hydrogen. But again, notice my 3 constants always in these reactions. So my furnace right now is, and yours is too, burning methane. That's natural gas, and it's going to always need some oxygen. And then there's water and carbon dioxide. And by the way, we're making water, which is weird, right? It's a gas, so that's why we don't see like liquid building up. These are all gases. So that is what I have. And then one last thing, I have a question for you. I want you to decide which type of compound, or not compound, sorry, which type of reaction are these? Decide if, what type is it: synthesis, decomposition, single replacement, double replacement, or combustion. So hopefully you had a chance to try those, and then here we go. This would be a double replacement reaction. The calcium and the hydrogen are switching spots, and a giveaway there is also compound, 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 compound. Notice I write water kind of weird, and we'll talk about that when we balance equations. This is water. It doesn't matter if you write it that way or this way. Over here, this is a combustion reaction. So how do I know that? I know that because I have a hydrocarbon, something that has carbon and hydrogen reacting with oxygen, makes carbon dioxide and water. So these three things are always going to be there. This will always be a hydrocarbon. This one here is synthesis, because they are combining and we only have one product. The opposite of synthesis right here, decomposition. And then this reaction, it's in a different order, but we have a single element going in and taking out a different element. So this is a single replacement. And so is this one. This is a different type of single replacement where it's the nonmetal taking out the other nonmetal. But again, one replaces the other. And it's different than a double replacement because we don't have two compounds. We have essentially an element, even though there's two of them because it's diatomic, and a compound. And then we get a new element and a new compound.